Okay, so I've started recording. Um, okay, so we should be all set to go. Um, okay, so quick show of hands or quick participation in the chat. How many of you have used LaTeX before? Um, for one thing or another? Okay, I'm seeing a lot of hands, a lot of thumbs up. That's very minimally. Okay. So it looks like we've got a little bit of everything. Some people have used LaTeX before, some a little bit, some not much. Um, so what I want to start off by saying is that I don't really claim to be an expert with LaTeX. I am sharing what I know, sharing what I've kind of pieced together over 4 or 5 years of using it. Um, but with most things, like with most things, there's more than one way to do this. There's more than one way to, what we're going to see is that you basically have to write in computer code, almost like a programming language, to get the output that you want. And like with most things, there's more than one way to do it. We will be looking at a few examples, and hopefully these examples are helpful. But really, we're just going to be barely scratching the surface of how to use LaTeX. I'm going to be sharing what I know, what I've used most often, which tends to be math and chemistry. But anybody that's interested in this, you can take a really deep dive into lots of different topics with LaTeX. So I have put together some slides for this, which we'll see over here on the right-hand side. And then over on the left-hand side, we are going to be actually working through some computer or some code for LaTeX. So let's see. I guess one thing I am seeing. Okay, there we go. All right. So title of this presentation, how to create publication quality documents, equations, and chemical structures with LaTeX. We're going to cover as much of this as we can. But yeah, I came up with about 50 some slides. We'll see if we actually get through all of this. But let me start off by just talking about what LaTeX is, and more specifically, what it isn't. It's not a word processor. It's not a photo editor, and it's not PowerPoint. Basically, what LaTeX is a typesetting system. You give LaTeX instructions, and then it figures out how to make your content look nice. Basically, it takes over, making the content look nice. All you have to do is tell LaTeX what you want to include. And you can be as specific with these instructions as you want to be. Again, the basic philosophy with LaTeX is that they are taking control, or they are basically saying, okay, we're going to make it look nice. But if you have some preferences, you can adjust these preferences to be as fine as you want them to be. And so there are a couple of online editors for LaTeX. One is Overleaf, and the other one is an equation editor. I mean, there are many more examples or many more online LaTeX editors out there. I find Overleaf to be the most comprehensive, and this is the one that I'm going to be working with today. These are active links, and so if you click on Overleaf, it will open their website. You do have to register for Overleaf, but you can register with your Gmail account, and I have used my Los Rios Gmail account for that. So I would encourage you to click on the link, register with Overleaf using your Los Rios account. It's totally free, and then follow along with what we're going to be doing in the rest of this presentation. I'm going to pause for just a minute because I realize that it does take time to navigate through, registering for, an online platform like Overleaf, or, well, this equation editor doesn't require registration, but it can only do math equations. So I would encourage you to use Overleaf. if you're okay with registering. Also, like I said, we're going to be going over lots of examples. And so if anyone has questions, please just shout out in the chat. Please let me know. I don't mind interruptions. That's kind of the point of this.
Hi, Steve.
Yeah, how you doing?
Oh, hi. Can you send the link where you can register?
Oh, yeah, let me do that. Let me put that in the chat. Let's see. I should be able to.
Thank
That's
you.
right. I realize copy link. I realize that you don't have access to the PDF. I'm so used to posting PDF files online on Canvas. But yeah, sometimes I do forget. Thank you.
Cool, thanks.
I have a question.
Yes.
The overleaf include everything, like including mathematical equation, or it doesn't include it? I'm just curious.
It includes most things. It
Okay.
includes everything that we're going to be using today. I can't say everything because there are a few things that Overleaf doesn't include. For example, I tried, when I was putting together this presentation, I tried putting together the script from Lord of the Rings that was on, the One Ring, and LaTeX can do that. You have to load some very special packages to get it to do that, and Overleaf didn't have those packages. But everything that I've really ever needed, equations, chemical structures, totally available through Overleaf. So yeah, the short answer is Overleaf has most everything, has everything you're likely to need.
Okay, thank you.
Oh yeah, you're welcome. Other questions? Hopefully everyone that wants to log into Overleaf has done that, has had time to do that. If anybody needs help or explanation, I'm happy to provide it as best I can. Trouble is, I've already registered, so I really can't show that process on screen here. Okay.
Just
I'm
one
gonna assume.
question. When I try to log in, log in. Can I use the private Gmail account or just only Los Rios one?
You can use any Gmail account that you want.
Okay.
Yeah, great question. You can use anyone that you want. And what's really cool is that you can switch between email accounts. When I first started using this, I used my personal email and then decided, hey, this is more relevant for work. So they totally let me just switch my account over to be associated with my work email. So they give you a lot of flexibility there, which is really nice.
Steve?
Yes.
Hi, this is Chu Ping. I tried to log in. It says use your institution registration, and I did that, but it wouldn't let me in. So
Right. So Los Rios doesn't have an institutional login. Basically, if you click on that button, it's asking you to log in through Los Rios, through Los Rios credentials. And what you need to do, let me see. Okay. So if it says log in to Overleaf, you don't want this button here where it says log in through your institution.
okay.
What you want to do is you want to click on this button here that says register.
Okay.
Don't have an account, you click register. And then you can say register with Google. And then it should give you a list of all the Google accounts that are currently logged in on your computer.
Okay.
Click on the one that you want to use. I used my Los Rios account, but you can use whichever you like.
Okay. Okay. Thank you. I'll try.
Oh yeah, you're welcome. No, I'm happy to spend time here. It's important that everyone who wants to follow along with this is able to. So yeah, I'm just gonna wait for another minute or two, see if anyone has questions. Okay. Not hearing any questions, so I think that means we are okay. Let me just re-log in here. Okay. All right. So there's 4 topics that I'm hoping to cover today. We're going to look at the structure of LaTeX projects. We're going to learn how to use LaTeX to make text documents.
Your song has joined the meeting.
Mathematical equations, and chemical structures. And so the first thing that we should do is click on this button here that says New Project. So if you click on New Project, it actually gives you a lot of different choices. I'm going to start with blank project, but it's worth mentioning that most of what I'm going to be covering in these first 3 sections, you can actually find under example project. But for us, we're going to start with a blank project, and I'm going to call this a text document. You could use any title you like there, but this shows you basically just a blank text document. And let me try to zoom in on this so that we can see a little bit better. There we go. Hide that to get a little bit better zoom. There we go. So we see a lot of text that shows up on this screen. And for what it's worth, this text can actually do something. If you compile it, it will put out, or it will spit out a text document with your name, date, and then a section for introduction. So we're going to be switching back and forth between the editor here and the output here quite a bit. But the first thing we really should do is understand what all this text means. You know, all of this, it's there for a reason. It all means something. But yeah, first, let's just take a look at what everything means and kind of what we need to be focused on when we're editing a LaTeX document. These first few lines here, so the first 1, 2, 3, 4, 5, 6 lines, these are what's called the preamble. These specify the basic settings for the document. Everything else, this is the body of the document. This is where the content goes. And so any global settings, these will all go through the preamble, and then the content, that's what you're going to see in the main body of the document. Now, again, there is probably enough information here that we could spend our entire time just talking about different settings. But just to go through some of the basics, let's take a quick look at the preamble. Preamble specifies a couple of important things. Specifies the document class and, document class options. We're just going to look at those for right now. For what we're doing, we can actually delete line 2. You don't need to, but we aren't going to be inserting any images, so we don't need this package here. I'm going to leave it just for the sake of not making any unnecessary changes. But what we're really interested in is line 1. And yeah, again, if you switch to PDF view, you'll see text document, your name, date, and an introduction. If you switch this to, let's say, book, and then we switch back to the PDF view, hit recompile, well, all of a sudden, this is going to be formatted very differently. This is going to be formatted the way that you would see a book typically appear, where you've got your title page here, and then different sections after the title page.
How do you switch to the PDF view, please?
Oh yeah, let's see. So let me expand this screen so you can, or actually I'll zoom out so you can see it a little bit easier. That button right there that says switch to PDF. So right there, switch to PDF. If you click on that, it'll show you the PDF. Any other questions? No, I appreciate the questions again. Hopefully everyone's following along. And so if anyone gets stuck or gets stuck, please do let me know. I'm happy to get you unstuck. Or if you have questions, believe me, there's
I'm
a lot of
actually
questions.
not seeing the switch to PDF on my overleaf right now.
Really?
Yeah,
Yeah.
neither do I. Yeah.
Oh. Okay. Well, let's see. Do you mind sharing your screen so that I can
I can share mine.
Yeah, go ahead.
Give me a minute here.
Okay. Yeah, take your time.
You've disabled participant screen sharing.
Have I?
Yes.
Okay.
There we go.
Okay, should be good.
So this is where it was on yours, but I'm not seeing it on mine.
Got it. Thank you. Yep, that's an oversight on my part. So what I've done to save space on my screen, so that way I could show both the go back to stop here. Right. So because I want to be able to show both the LaTeX and slides, what I've done is I've closed, there you go, the PDF output. So all you need to do is say recompile, and then that will show you the text output here.
Okay.
Now, if you want to have it look exactly like my screen, you can hit this little arrow, closes that screen on the right, and now it has you switch back and forth. Thank you. Yep, didn't even think of that. I appreciate the question. So yeah, if your screen looks like this, that's totally fine. All you have to do is say recompile. And then just show one other thing. We can say letter here. That's just another document class. If you recompile, it'll look a little bit different. All the title stuff will be gone, and the only thing that'll be there will be the introduction. Okay, let's get that. So while we're looking at this with a full screen view, the other topic, the other idea that I want to introduce is this idea of options, where basically you can put options for, well, lots of different things, but here we're looking at document class. And the options, they go right here in brackets. And so let's switch, I'm going to switch this back to article because I think things are more impressive. It's more of these changes are more obvious when we're looking at an article. And so I'm going to switch back to article, and we see title, name, date, introduction. There are lots of different options that you can specify here. A couple that I'm going to show just for the sake of example will be changing it from portrait to landscape. And so right now it's in portrait, that's the default. But if we want it rotated by 90 degrees, we would say landscape, recompile, and then, yeah, we see that our text is showing up in landscape. That's one possible option. Another option would be to adjust the paper size. Again, the default is letter 8.5 by 11. But if we want legal, for a legal side or a legal pad, we could say instead of letter paper, we would say legal paper. So I can just type that in here. Legal paper, recompile, and you'll see that the size changes. There are many, many, many different options that we could use. These are just a few. You can adjust the default font size. You can adjust the style. So if you want like a serif versus a sans serif font, those are all things that can be adjusted here. But rather than get out into the weeds with that, I just want to introduce the idea that you can specify options here. They are in brackets before the document class type. I'm going to pause for a second just to see if anyone has questions. I have, let's see.
Steve, I'm sure it's gonna come up, but is the
go
document
ahead.
is the document you create here exportable, or is other documents importable to other software like word processors?
That's a great question. And to be honest, I wasn't actually going to spend a lot of time with that. And so, no, it's a good question. I'm very happy to address it now. If you want to export this, hang on, let me send this back to its default. If you want to export this, you just click on this button here that says download PDF. Click on that button, it'll download the PDF file of whatever you've created here. So if I downloaded that, it would go to my computer. You could then upload it to Canvas. If we're talking about like a chemical structure, you could then edit it with your photo editor of choice. But to answer your question, yep, the export button is right there. Yeah, it's a great question. Anyone else?
Thanks.
Can you download as a JPEG by any chance?
You can't, not
Okay.
from this. So what I usually do, and again, these are great questions. They were out of the scope of LaTeX. So I didn't include it in here. Maybe I should have. But basically what I do is I download it as a PDF and then we'll usually import it to, a photo editor and export as a JPEG from there. Part of the reason why I do that is because, it's a text document. We wouldn't have much reason to have it as a JPEG. But once we start getting into either equations or chemical structures, it actually makes sense to crop those a little bit before importing them into another document. So it's a little frustrating, I suppose, that that you can't export as a JPEG. But I haven't found that to be really that onerous of a follow-up step. Hey, let's see. I'm going to switch back to go. Okay, so we've learned about different types of document classes and different options that we can apply to those classes. Let's start off very briefly by talking about text documents. I say really briefly because I don't actually want to spend a lot of time here. For my use case, there's nothing that LaTeX can do here that a good word processor like Microsoft Office or LibreOffice couldn't do. To me, where I want to spend most of the time, we can hopefully spend most of the time on mathematical equations and chemical structures. But the roots of LaTeX, shall we say, is in text documents and typesetting. So I would feel remiss if I didn't talk about this at least a little bit. So what we're looking at now is in the main body of the document. We've looked at a few things in the preamble, but now we're looking at everything in between begin document and end document. And what we're going to be really looking at here are the sections. Here we have a section for introduction. We actually don't need introduction. What I'm going to do is make a section for text and then another section for formatting text, another section for hyperlinks, and another section for accessibility. And so really you can just use the where it says section and then in brackets introduction, just use that as a template. But instead of introduction, you just say text, formatting text, hyperlinks, and accessibility. In fact, I actually did that the long way. What you could do just as easily is just copy, paste, and then replace what's in here. So hyperlinks, and then paste accessibility. So we have 4 sections that we're working with. And then if you either say switch to PDF or recompile. Now I realize this is probably a little small to see, so let me enlarge that. So now LaTeX has taken care of adding all these things in for us: text, formatting text, hyperlinks, and accessibility. So the 4 sections that we've wanted to add, LaTeX is now calling these sections 1, 2, 3, and 4. Okay, so let's look at text. For text, adding text to LaTeX is actually really easy. You just type in what you want to say, the same way that you would a word processor. So I realize that you can't copy and paste this, but you can type in any text that you want. So I just said adding text to a document is easy. Type the content the same way that you would in a word processor. And then if you say recompile, it'll insert that text, whatever you put in, right there for you. And it'll just take care of, one paragraph after another, pretty much the same way that a word processor was, except because LaTeX is a typesetting program, it will basically take care of making the text look nice for you. Everyone with me so far? Any questions? Okay. Well, let's talk about something a little bit more interesting, shall we say? Formatting text. So let's see, I do need to get my notes here. Whoops. There we go. So when it comes to formatting text, there are lots of ways that you can format text. I'm going to focus on 2 things: text size and bold, italics, underline, things like that. And so if you want to format the size of text in LaTeX, I'm just going to write out something like this: the font size of text can be modified in LaTeX. Okay, so if I recompile that, well, font size here, it's exactly the same as the font size here. That's because we haven't taken the time to modify it yet. The way that you modify font sizes in LaTeX is with these commands here. So if you type in one of these commands in front of the text that you want to modify, well, LaTeX will take care of making the text tiny, small, large, huge, or any of these options in between. And so let's try a few of these out. Let's say that we want to make this huge. So the font, we want that to be huge. So if I recompile, well, it worked, kind of. But because LaTeX is kind of like computer programming software, it is very, very literal. It says, okay, great. From where you tell me to increase the text size, I'm going to do that until the end of the section. But let's say that's not what we wanted to do. Let's say that we just wanted this word size to be larger than all the others. And so what you have to do is you basically have to tell LaTeX to go back normal size, whoops, except not there, after the word size. So we start huge text here, and we go back to what LaTeX considers normal here. So now if we recompile, okay, that looks a little bit more like what we wanted. And at this point, I would encourage you to, play around with other commands that we see here, where you can do tiny, script size, large, 3 different versions of large, and they all produce a slightly different size. But they all work exactly the same way. And so if we want to do really small text at the end of that sentence, well, we can say tiny, and you can see that these words are smaller than the ones around them. So yeah, font size can be modified in LaTeX. Questions so far? Everyone with me? Hey, talk about one other thing that can be modified using LaTeX, and that is bold, italics, underline, etc. And so let's say, don't need that anymore, so I'm going to get rid of it. Let's say that text can be bold, italics, or underline. So there's the text that I want to modify. Modifying text this way works a little bit different than what we saw before. We saw before, you put in this command and everything following that command would be the corresponding size. What you need to do here is here, let's say we want this word bold in bold. We need to use this command, text BF for boldface, and then everything in brackets will be in bold. So I want the word bold in bold, so that's what I put in brackets. Here we have text IT for italics, and that's what we want in italics. And here we have underline, and in brackets is everything we want underlined. And if we recompile this, we can see that these commands had their intended effect: bold, italics, and underlined. So yeah, bold, italics, and underlined. There are other ways you can modify text in LaTeX. These are just the most common, so they're the ones that I wanted to show. Any questions so far? No questions right now? Good. Okay, so for the sake of time, I'm actually going to skip over hyperlinks. If anyone's interested in this, yeah, if anyone is interested in this, I can send you these slides. This is very easy to find either in an example or on Google. But I would like to move on and talk about math and chemical equations. But I would be remiss to not talk about accessibility. So accessibility is something that is included in LaTeX. LaTeX can create tag structured PDF files. Again, there's a lot that we can talk about here, a lot of different ways, obviously, that content needs to be made accessible. But a lot of that can be handled through the accessibility package. So what you would need to do here is go back to the document's preamble, say use package accessibility, and tell LaTeX to create tag PDF file. And so if you add this code to the beginning of a text document,
You've got a C missing in package there.
What's that?
The letter C is missing in the word use package.
Thank you. Thank you. That would have not worked out if somebody didn't catch that. Yeah, so very sensitive to typos, but fortunately, if you try to compile a mistake, it's pretty good at letting you know. But yeah, if you include this code, it creates an accessible PDF file. I've tested this on Canvas, and this very simple document does get 100% on our accessibility checker. Obviously, that we know our accessibility checker isn't perfect, and so there's a lot more we could talk about here. But this package provides a really good start. So we can recompile. This text really won't change much. But if you then download this file, upload it to Canvas, you will get as of right now, you will get a perfect accessibility score. So accessibility, obviously something that's really important to think about when you are creating documents using LaTeX. The good news is LaTeX does have accessibility packages built in. So yeah, good for them. Okay, I realize I skipped over a few things here. To get through text documents, you can include hyperlinks. But really, where I find LaTeX to be especially useful is with math, equations, and chemical structures. So this is where I wanted to spend a little bit more time. I feel at this point we've gotten an introduction to how LaTeX works. We've looked at document classes. We've seen how to load packages. We've looked at different options, and we've added some content. And so we're well on our way to understanding basically the nuts and bolts of how LaTeX code works. So at this point, I'd like to switch gears and talk about mathematical equations. There is a LaTeX equation editor in Canvas that can do mathematical equations. I've used that quite a bit. I believe there is a plugin on LibreOffice, which is what I use for making text documents. That's my word processor. So mathematical equations, you can use these in a lot of different places. But to do this, what I would actually like to do is start a new document. We have a lot of content here. Be ashamed to lose it. So let's click on this button here that says back to your projects. It's in the upper left. I'm going to create a new project, blank again, and I'm going to call this mathematical equations. So we have a new project, and I'm actually going to take a few things out of this just for the sake of simplicity. We don't care about title, author, and date, so I'm going to get rid of those. We don't care about making a title, so I'm going to get rid of that. We don't care about the introduction, and we're not going to be using images. So really, all we need at this point are these 1, 2, 3 lines. We've got our document class, the start of the document, and the end of the document. Everything else in between, that's just our content. And so what do we need to do to get math equations to work? Couple of things to start off with. Instead of an article, I use the standalone document class. You certainly don't need to use a standalone class, but this allows us to produce just the equation that we want and nothing else. If you try putting that equation in an article, depending on the document class, LaTeX is going to want to modify it or embed it in a document in some way. If we use standalone, it's just the equation that we're interested in. I find this to be a little bit easier. And so you can use different classes here, but modifying that to standalone, helpful. The other thing we need to learn about or talk about before we can start writing equations is what's called math mode. There are a few ways to tell LaTeX that, hey, I'm working with a math with a mathematical equation. Hey, I'm in math mode. All of these, for our purposes, will work exactly the same way. I'm just going to use this, where if you put your equation in between dollar signs, that just tells LaTeX, hey, I'm in math mode, so treat everything in between here as an equation. Now, the other thing that you want to keep in mind, there can't be any empty lines between these delimiters, between the dollar signs. We'll talk about that in a second, but what a lot of people actually do is just have them right next to each other. So that way you don't run any risk of unintentionally having extra lines in here. Personal preference, I just like to have these on separate lines. I'm just being careful that there aren't any empty lines. So that having been said, let's write an equation. Something really easy. Y equals 3x plus 4. So that equation for a line, y equals mx plus b. In this case, I have 3x plus 4. And if you hit compile, well, it gives you just your equation. And so, whoops. And so, this isn't cooperating here. Okay, well, we'll switch back and forth between the editor and the PDF. So yeah, y equals 3x plus 4. There's our equation. Now, when I've said you have to be careful to not put any blank spaces in between these dollar signs, what I mean by that is if you did this and you tried compiling, it would yell at you. Sure, it still did what you wanted it to do, but it did produce a few errors. When you get more complex equations, it won't even give you an output. So really important. Yeah, see here, it's complaining. You don't want to have any empty spaces in between your dollar signs there, or whatever delimiters you use to tell it it's in math mode. So we've just gotten the equation for a line, but we can get a little bit more complex than that by adding in fractions. So fractions, you need to use this command here that's highlighted in blue. And so if you do that command, let's replace 3 here. So instead of saying y equals 3x plus 4, let's say that we want 1/2 here instead of 3. Let's say that we want this equation here. So in order to do that, we have to set up a fraction with 2 sets of brackets after that command. First set of brackets is the numerator, second set is the denominator. So if we want 1/2, we have 1 in the numerator, 2 in the denominator, and that should give us our fraction, 1/2 x plus 4. I'm going to pause for a second. Anybody have questions? Again, we're just kind of working through different things.
Could you go back to the code on that? Just so I
Yeah,
can-
by all means. There you
Oh,
go.
thanks. Great.
Yeah, so I'm going to pause for a minute just to see if anyone has questions. You can try different things here as well. Let's say you didn't want the equation to look like that, where it's 1/2 x, but let's say you wanted x over 2. Just as easily have done that, and that would work as well. And so this comes back to the whole idea behind LaTeX is that, yeah, you tell it what you want, it figures out how to make it look nice. But these are fractions.
What about for other operations like square root or
It's a great
sine or
question.
something? Yeah.
Yep, it's a great question. I don't think I have square root here. But yeah, we're just going to look at other things like exponents, subscripts, Greek letters, trig functions, and then expressions. That's what I had here. I didn't get the square roots or cubed roots or anything like that. just a choice in terms of content. But let's say that we wanted this equation. So again, we're basically just modifying the equation that we, there we go. We're just modifying the equation that we started off with. Let's say that we want x squared here. So to get an exponent, you use the caret. Basically, it's shift and then the number key 6, and then 2 sets of brackets. Anything in those brackets will then be in an exponent. So if I want x squared, well, that's the highlighted code right there. Use the little caret. Everything in those brackets is going to be the exponent. And so if I recompile, I now have 1/2 x squared plus 4. And so, yeah, that's how you would do an exponent. One thing I should mention here, and this is just kind of a style thing or a personal preference, LaTeX can, or the way that this works is it chooses the one thing after that caret, and it says, okay, if you don't include the brackets, that very first thing after the caret, that's the exponent. Now, where you can get in trouble with this is, let's say that we didn't want to say x squared, let's say we wanted to say x to the 12th. Okay, well, we have our caret, we have our x to the 12th. Great, should work exactly the way that we want. Only it doesn't. Because again, LaTeX is very literal. It says, okay, that first thing, there's your exponent, and then we're back to not having an exponent with that next thing. And so for that reason, everything that I want in the exponent, I just put it in brackets, even if it's just one number. That way, I don't get surprised. I don't forget, oh yeah, it only takes that first number. If we have 2 numbers that we want in an exponent, we have to use brackets. So I've just gotten in the habit of always using brackets. Again, personal preference, but I've found that works pretty well. We can also do subscripts. And so here we're getting into a little bit of chemistry. This is P1 V1 equals P2 V2, one of our simple gas laws. But this gives us a really good practice or really good example for subscripts. So we want 1 and 2 to be, yeah, slightly lower than everything else. So here, subscripts, we use the underscore, and then I just enclose the whole thing in brackets. P1 V1 equals P2 V2. And so all of our subscripts are in brackets. And if I recompile those, I get Boyle's law, one of our simple gas laws from chemistry. P1 V1 is equal to P2 V2. Anybody that wants a little extra practice or wants to work ahead, you can use, or you can see if you can figure out this equation here. This one combines fractions and subscripts. So to get this lower equation here, you need to use the command for fraction and subscripts as well. But for the sake of time, I'm not going to go over some of these more, shall we say, complex examples. But I am going to pause for a minute and see if anyone has questions. Again, we're just kind of learning one thing at a time. This is by no means an exhaustive list.
I have a question.
Yeah.
If you want to type 2 different equations at the same time, what should we do? Like not just one equation, like 2 equations at the same time?
Oh, okay. So if you wanted to have like both of these in the same.
Yeah. Then you need
That-
to do $sign one more time, or how do you do?
That's a great question. So there's a few ways you can do it. Right now, I'm just putting in one equation just because I think it's easier. Personally, what I would do is what I did here is each one of these is its own picture. So here's, the first thing that I put into the presentation, there's the second one.
Mhm.
If you wanted both, what you could do is you could just add space in between. And then let's see. So I'm just going to put in that equation twice. Whoops. I'm just kind of guessing here. Yeah, you can put in space in between. I'm sorry, I'm not remembering how to put in vertical space. Somebody else probably knows. Somebody else probably saying, oh, I do it this way. But yeah, I don't remember. I know how to get horizontal space. And I know there is a way to do it. It's pretty much, it's very use case specific. But it's a use case that I don't encounter a lot, which is why I don't remember it now.
Yeah. Another question is, you type it and it automatically saves in the project, or do you need to click something?
In this online editor, it automatically saves.
Okay.
Yeah, it automatically saves.
Okay.
If you were to have this installed on your computer, then no, you'd have to save it like you would a text file. But for this, it does.
Okay.
Yeah, great questions. Anyone else?
Yeah, you can install it on your computer, work offline.
Yes, yes.
Oh, great.
Yep. And the advantage to that is that, well, you can work offline, but also, yeah, the advantage to that is you can load all the packages that you want. And so if something isn't included in Overleaf, but you want it, then you can just go ahead and install it, which actually is it's not that hard. And it's free. This is, completely free software to install. And so it's, yeah, completely free of cost. If you want to install this on your computer, you can and not have to pay anything.
Is it the same process to how do you install on your computer?
It depends on your operating system. I mean, obviously, but I think you can just download it from, if you just Google LaTeX,
Okay.
latex.com, it'll give you download instructions. If you want to stay after this is over, I'd be happy to show you, or be happy to look at that. But yeah, I didn't really want to ask everybody to install software on their computer for this. So yeah, that's why I didn't include it here. But yeah, I'm going to pause for just a second to see if anyone else has.
You said
That's
you
questions.
download LaTeX. You don't download Overleaf.
No,
Oh, okay.
you would
So
download.
Overleaf just an online version.
Right, this is just an online version. Yeah, so you would have to download the software that this website is running in order to get this output.
Is there a carriage return command?
Yes, can you give me a little bit more context there? What exactly are you looking
Like I
for?
want an equation on one line and then an equation on the next line.
Oh, yeah, that
I mean, you were trying to do that earlier, but it didn't work out.
yeah, there is one. I've done it before. I don't remember how to do it.
Okay,
Yeah, that yeah. Talk to me after and I mean, I'm sure a Google search would tell you how to do it, but yes, you can do that.
I have another question related to that. Like you
Mhm.
put the equation and then is there a way to draw the graph out of it on the LaTeX or?
Is there a way to get the graph? Yes. But that is, so I believe so. I don't actually know that for a fact, whether it's possible to get a graph. I have made graphs before using LaTeX, but I haven't done it based on an equation. But the cool thing about the way that software like this works, where the code it's free. What people can do is install or basically write packages that can add on to the code. And so, way back when this software was first written, when it first started, it was a typesetting program for documents. But then, people have come along and added the functionality that they want. I would be very surprised if that functionality, if nobody else wanted that functionality. So I'm guessing it's there. I've never used it. But I'm guessing a Google search will show you how to do that. So let's see. We've gotten through subscripts. We also have Greek letters and trigonometric functions, mathematical expressions. We could absolutely continue on with this, but I do want to spend the last 20 minutes going over chemical structures. So I'm sorry for skipping a few slides and sorry for perhaps ignoring or perhaps skipping a few questions. If we have time at the end, I'd be very happy to go back and look at more math topics after this is all over, or after our time slot is over. But the last 15 to 20 minutes, I would like to go over chemical structures. So let's talk about chemical structures. For chemical structures, I also use the standalone document class, but here I put in a border. And the reason for this, well, there's a couple of reasons, but if you notice with these equations, you see how very closely cropped that this picture is, where it's just right up to the very edge of our subscripts in this case. That can actually be an inconvenience when you're making Lewis structures and things like that. And so what I do is I add a 3 millimeter border. Border equals 3 millimeters into as an option to the document class. And so now, if we think about the last equation that we worked with, there is our there's our equation, but with a little bit of space around it. This helps a lot when I'm working with chemical structures. So border equals 3 millimeters, put that in the document class. And I'm also going to get rid of everything we needed for math. Now, before we can start making chemical structures, chemical equations, we have to add in the chemistry package. Now, this is an example of something that has been added to LaTeX, is that, this typesetting program was first developed, and then a bunch of chemists said, hey, we really want this functionality. So they wrote this package, and if you want to, you can then include it into your version of LaTeX. Fortunately, the people at Overleaf did. And so if we say document class chemfig, well, make sure I spelled that right, chemfig, now we can make chemical structures. This basically just adds extra functionality to LaTeX by telling it, hey, you need to call in this extra program. So we've added chemfig as a document class. And then we need to do is add chemfig to the body of our document as well. And so here we say chemfig with 2 brackets. Now these brackets are pretty much like the math delimiters that we saw in the previous section, where it's, hey, everything in between these brackets, yeah, that's the code, that's the instructions for our chemical equation. Again, you don't want any empty lines in between the opening, closing brackets, but everything that you type in here, well, that will create different chemical structures. And so in order to, one other thing, I almost didn't include this because you don't need it, but atoms are called charges in LaTeX. Don't ask me why, but yeah, these are called charges. And these are just options that over time I've found just make things look a little nicer. You don't need to include this. You don't need to understand what these mean. But for the sake of having output that looks nice, I'm going to say set charge circle equals true. Extra separation, extra equals 2 point. So you can include that or not. I'm going to put it in just so the output looks a little bit nicer. But again, totally optional. Okay, so let's start with drawing atoms. So atoms, molecules, these can all be described by what are called Lewis structures. And Lewis structures, this is a tiny little bit of chemistry that we're going to talk about in this presentation. Lewis structures are based on valence electrons. Each valence electron gets a dot. So basically what we want to do is take any of these chemical symbols from the periodic table and then add the correct number of dots around. And we're going to get things that look like this. So here we have Lewis structures for lithium, beryllium, boron, a whole bunch of different elements. So how do we do this? Well, in order to figure out the right number of dots, we need to know how many valence electrons an atom has. And to do that, you just look at the group number. And so I'm just talking about main group elements here. I'm sorry to be glossing over so much chemistry. But let's say that we wanted to draw the Lewis structure for carbon, which is right here. You look at the top of the row and you see it says 4A. So that means the Lewis structure for carbon is the letter C with 4 dots. So the question is, where do we put those dots? And again, at this point, we're taking a little bit of a step back from chemistry and saying, okay, how does LaTeX work in this case? These are positions in the ChemFig package in LaTeX. Now, you can define positions in 2 different ways. You can have the relative positions, or excuse me, you can have predefined angles, which are shown in black, or absolute angles, which are shown in red. These are all relative to horizontal on the right-hand side. So horizontal on the right-hand side is 0, and then you just increase 0 to 360 degrees, moving counterclockwise. So if we wanted to put dots on top of an atom, you'd have to say, okay, we want it in predefined angle 2, or what I'm going to work with at a 90-degree angle. So let's work with, we'll work with fluorine. So fluorine is here. So that means it has 7 valence electrons. So we need to put the letter F with 7 dots around it. But we can't just draw the letter F. So if I said, okay, there's the letter F. Okay, we would get, hang on one second. We would get LaTeX complaining at me. Let me get rid of that just for now. Okay, so there we go. Okay, so we could get the letter F, but we won't be able to place any dots around it. For this, we need to use the charge command. So again, why the authors chose to call this a charge command, I don't know. But once you have the charge command, you're telling LaTeX, okay, we're talking about an atom, and you have 2 sets of brackets. The first sets of brackets tell you where you want to put the dots. Second set of brackets tell you the atom that you're working with. And so in this case, we're going to say fluorine, and we want to put 7 dots around fluorine. So we're trying to recreate this structure here. So we know that we're going to have dots at 0, 90, 180, and 270. So 0 equals, 90 equals, 180 equals, 270 equals. So this just tells us, or I'm basically just setting up our outline. At 0 degrees, we have something. 90 degrees, we have something. 180 and 270. So what are those somethings? Well, you can either have 1 dot or 2. 1 dot is specified as slash with a period, so just 1 dot. And then if you want 2 dots, you have a colon, 2 dots, oops, excuse me, slash, and then a colon. And so we want 2 dots at 0. So 2 dots at 90, 2 dots at 180, and 1 dot at 270. So we recompile that. Let's see. It is,
I think you got a problem on line 2. Your use package somehow turned into document class.
thank you. Thank you very much. And that would also explain why that didn't work. So yeah, I didn't do that on purpose, but that gives me a very good opportunity to say, yeah, this can be a little bit fussy. Errors in one place can cause things to stop working in unpredictable ways. And so thank you very much for catching that. Yeah, not document class, use package. So now charge will work. And so with this information, we really could go back and recreate any of these Lewis structures. And so, for example, if we wanted oxygen, well, here we have at 0 degrees on the right-hand side, we have a single dot. So we give that a single dot. And then at 90 degrees, we still have 2. 180, we still have a single dot. And then at 270, we have our 2 dots here on the bottom. And so if we recompile, whoops, of course, I've forgotten something here. We don't want fluorine, we want oxygen. And there we go. There's our Lewis structure for oxygen. And so understanding how this charge command works and also understanding the angles, the relative positions of things in LaTeX, that to me is actually the most challenging part of making these structures, is saying like, okay, well, I need this one at a 90-degree angle. I need this one, at 180-degree angle. Once you have that, building more complex structures, it's actually not that big of a jump from here. Any questions so far? I'm happy to answer more questions about this. But hopefully we're all caught up. Hey, since we are running a little short on time, not a surprise, I am going to talk about how to use LaTeX to draw the Lewis structures of molecules. So molecules, a little bit of chemistry, are groups of atoms that are held together by shared electrons. Shared electrons are called covalent bonds, and they are represented as dashes. And so if we wanted to show 2 atoms that are stuck together by a covalent bond, we have a couple of choices. It's actually not the best example at this point, but if we want to do a single bond, we just use a single dash. And so, for example, if I wanted to say that 2 chlorine, or we'll say 2 fluorine atoms are stuck together, well, I would just say F and then a dash to fluorine. And that dash would be interpreted as a line in LaTeX and give you your single bond. Now, I am ignoring any lone pairs on this fluorine, but just because we're running out of time, that's okay. I wanted to show how to make a single bond. If you want a double bond, well, you just use the equal sign, because that now has 2 lines. And so if I recompile, it gives us a double bond. Now, fluorine not held together by a double bond, so I'm going to say this with oxygen. But yeah, now there is an oxygen molecule. Triple bond. Let's see, we get caught up here. There's the command for a triple bond. And of course, we're not going to use nitrogen or oxygen anymore, but nitrogen. So there we have a triple bond. And so, yeah, there are your commands for single bonds, double bonds, and triple bonds, as well as lone pairs. Now, in this case, let's actually have a look at how to add these double bonds, because at this point, we actually have everything that we need. We have the relative positions within LaTeX. We know how to add bonds, and we know how to add lone pairs. And so from this point on, making more complex structures is actually pretty straightforward. Yeah, instead of looking at lone pairs here, let's have a look at the Lewis structure of CH4. So here, what we would want to do, we can actually do this in a couple of different ways. The way that I usually choose to do it is by defining that central atom. Carbon is in the center. And then if we have atoms that are attached to that central atom, you just define those with parentheses. So each one of these parentheses is for our hydrogens. So we have carbon in the middle. There's one hydrogen, another hydrogen, third, and fourth hydrogen. So we want one hydrogen, single bonded at 90 degrees. And the nice thing about LaTeX is you can kind of check your work as you go. You can say, okay, well, there's a single bond, 90 degrees to a hydrogen atom. Hey, well, there's that one single bond. And so we can basically just repeat that step, except instead of at 90 degrees, we just say, okay, we need another one at 180, another one at 270, and one at 0 off to the right. And so if you recompile that, there's your Lewis structure. And I realized at this point, we're pretty much out of time. There was a lot more that I wanted to talk about, maybe in a future Flex event. But using these basic ideas for chemical structures, you can actually do quite a bit. Yeah, you can actually make some pretty complex chemical structures using just these basic commands. But yeah, so I'm sorry to have to cut this off, but we are 2 minutes away from time. I'd like to see if anyone has any last minute questions.
Yeah, is there a way we can get a copy of the slides?
Yeah, I'd be happy to. Yeah, tell you what, I'm trying to think of the most efficient way to do that. If you want a copy of the slides, just drop your name in the chat and I will just send everything to your Los Rios email address. Yeah, and in fact, let's see. Give me 1 second here. So there's my email. If you want these slides and I don't get them to you in the next couple of hours, just send me an email and I'll send you a PDF for all these. So yeah, hopefully this was helpful. Hopefully this gave everyone an introduction to LaTeX, but really with just a little bit of planning. Really, for me, planning ahead is what's the most important. This is, yeah, another chemical structure that you could make. And again, you're just seeing kind of these same basic principles expanded out to just a more complex molecule. So yeah, thank you everyone for attending the Flex event. Thank you all very much for all of your very good questions. I very much appreciate it. If anyone does have more questions, I'm happy to stick around. But yeah, at this point, since we're just on to questions, I am going to stop the recording.